Hello, students. We're continuing talking about triangle congruence. Today we're talking about angle side angle triangle congruence. Just a quick review. What are we doing right now? We're doing proofs, and proofs use deductive reasoning. Deductive reasoning is the type of thinking your brain does when it takes given information, all these little pieces of things that we know, definitions, theorems, postulates, properties from algebra, agreed upon facts. That means they're in writing somewhere, usually in the textbook, as supporting evidence to reach a true conclusion. This is heavy lifting for our brain, okay? And it's something that our society really needs. In a proof, we link the statements with their reasons, much like we would link the hypothesis of a conditional to its conclusion. So let's take a step back. Here's a triangle. What do we see? Whenever you have a figure, that's the first question you want to ask. I see angle M and angle N are different sizes. What kind of triangle do we think it is? Do we think it's obtuse or scalene? What about angle L or right? Angle L almost looks like a right angle. Is it a right angle? No. If it doesn't have the box in it, we cannot assume that it's a right angle. But it's not. Okay, it looks a little bit obtuse to me, so I might have to get a protractor out and measure this. But I'm going to, I can also put the corner of a piece of paper here. I'm going to say it's an obtuse triangle. What markings do we have? What markings do we have in this picture? Yeah, we have angle M is marked. Angle N is marked. What else is marked? This line segment, this side MN is marked. Okay. I also know that these two sides are different because these two angles are different and the sides opposite are different. So I also know it is a scalene triangle. This is less important, but it is kind of interesting classifying what kind of triangle it is. So in this figure, if you have a figure marked this way, we call this angle side angle. Because where is the side? The side is included between the two angles. The side, if I'm looking around this triangle, I have a mark here for the angle. I have the side right next to it, and then I have another angle. So this is the included side. That's different than if you had a picture of a triangle and it was marked like this. If I had this angle and this angle and this side, this would not be angle side angle. This would be something else. Okay. So when you look at these problems and you're looking at a triangle, you want to decide if the side is included or not included. Okay, so let's prove it to ourselves that these would match up. And the way we could do that is with a composition of rigid motions. That's one way to prove that triangles are congruent. And what would I do? What would I do to show that triangle ABC maps onto, and I wrote that a little too close, triangle, wow, that should not say DEF or ABC. That is a mistake. How confusing. Okay, this should say triangle LMN maps onto triangle RST. Okay, so what do we do to triangle LMN? to show that it's going to match up onto triangle RST. And there's lots of ways to do this. I am going to take M and put it right onto S. And it's a little hard to see. Just pretend this program is slightly limited. Let's pretend like I put point M exactly on point S. Okay, then what do I need to do? And I'm going to need to rotate it. And again, it's a little hard to see, but we'll maybe rotate just a little bit more. This. Okay, so they're in the same, M is still on S. And then what's the last step that I'm going to need to do? I'm going to need to, once I get it right up next to it, I'm going to flip it over. Okay, so that's my plan. I'm going to first translate. I'm going to translate the whole triangle. So M goes exactly onto S. Oops, let me write that a little closer. Lots of mistakes today. That's all right. Mistakes are tools that allow thinking to happen. All right, so we got M, we're gonna go put it on S. And then after that, what did I do? I rotated. Capital R or lowercase r? Good. I rotated, and I don't know how much I rotated, but I rotated some amount. Maybe, I don't know. How many degrees was that? Like 60 maybe. And I rotated around point S. So I moved it over. Let me just show you one more time. We moved triangle M and N, L, M, N, and then we rotated it a little bit around point S and M. Okay, and then the last thing that we have to do, what's the other R stand for? We have to reflect it. And where did we reflect it? Well, we're going to reflect it over line ST. This is one way you could write how to show that triangle LMN matches up on triangle RST. All right, now we're going to do the traditional two-column proof. So we have our figure, and we're going to be given the figure as marked. And we're trying to prove that the triangles are congruent. We're trying to prove that triangle, should we do JKL is congruent to triangle? All right, we got to get it all in the right order. So J didn't have any marks, so M is going to come first. It's not always alphabetical. A lot of these that I set up are alphabetical, but it doesn't have to be alphabetical. Okay, and then we have, what did I say? M and J both don't have a mark. And then I did K. K has one mark at the angle, so I need N next. And then O is the last one. Okay, and what goes over here? Good, statements. And what goes over here? This is our supporting evidence. These are reasons why we know these things are to be true and why no one can argue with us, because we know for a fact that it's true. And this is a nice, straightforward four-stepper, and I'm just going to list them out. What order do you think I'm going to put them in? I'm looking at it, I'm going to start with K and N. Angle K has the same mark and is the same size and shape as angle N. How do I know they're the same? They have the same mark. And how do I know they have the same mark? Because it was given in the figure. Okay, I've showed a pair of angles are congruent. What am I going to do next? Remember, I'm trying to get to the end. I'm trying to get to this proven statement where triangle JKL is congruent to triangle MNO. And we know what the title of this lesson is, right? So we know what reason we're trying to use at the end. Okay, I showed a pair of angles. Now I'm going to do the pair of sides. So I'll do side KL is the same size and shape as side NO. Also given to me because they have the same mark on them in the figure. All right, so I've showed a pair of angles that's congruent. I've showed a pair of sides is congruent. I'm going to show the last pair of angles are congruent. So I'm going to keep starting on the left triangle and compare it to the right triangle. Just helps people reading my proof be able to understand what I'm doing. Angle L is this congruent to angle O, that's given. I have very clearly shown that I have a pair of angles on both triangles that match up. The sides included that match up and are congruent, and another pair of angles that are congruent. So I am allowed to use the angle, side, angle, triangle theorem. Okay, that's the easy one. This one is way more fun. Lots going on here. Okay, so I have the figure, I have the given information, and I have what I'm trying to prove. This is the fourth example for your practice problems on the worksheet. Okay, so before I start a proof, I just stare at it. I just look at it. It's like, oh my gosh, what do we have here? So I see a right angle. What else do we see? I see a big triangle, triangle ABC. I see that I'm trying to prove that triangle ADB, so the one on the right, is congruent to triangle ADC. Do they look congruent? Yeah, they do. So I think they will be. I see that line segment AD, which is here, bisects angle A. Anyone know what the word bisects means? You want to look it up? What is an angle bisector? Okay, angle bisector means it cuts the angle in half. And if you actually look at the definition, it's a line segment or a line or a ray that divides an angle into two congruent angles. This is just my thinking. So if sometimes I use like another color to mark my figure. So let's use red. If line segment AD bisects angle A, here's angle A right here. And if it cuts it in half, what does that mean? That means this half and this half can get the same one little arc across them. And I'm going to be lazy and call this angle 1 and angle 2. Okay, so I know somewhere in my proof that I'm going to be writing angle 1 is the same as angle 2. Okay. All right, that's good. That's going to be a part. That's going to be one of my statements here. All right, what else do we know? We know, oh, they're smashed together, right? So they share a side. Does anyone remember what it's called when the side of one triangle is the same as the side of another triangle? Or a way to say that this is the same as this? Good. I'm going to put a little mark on there. Okay, that's side AD on this triangle is the same as side AD on the other triangle. Do we remember the reason for that? We'll get to it when we get over here. Okay, what about down here? So I've showed an angle, I've showed a side. How do I know how much this is? How much do you think that is? Good. Okay. I think that angle ADB is also 90 degrees. But how do we do what if someone doesn't believe you? How do you convince them? What reasons can you give to support that? Yeah, maybe you know that it's next to a 90-degree angle. And what do two angles next to each other on a straight line make? 180. Okay, so maybe you could use that word supplementary. And maybe you could use a linear pair. Linear pair means the two angles on the straight line. All right, we'll see what we do with that. So I've done some brainstorming. I'm going to come back and get some of my statements. In this proof, I'm going to start with the statement that's given, because then I don't forget about it. I also want to do angle, side angle, so it's good to start with kind of the angles here. This is given. And I'm also going to do that first step. So angle 1 is congruent to angle 2. Now, how did I know those were the same? Because I know what bisect means. So this is going to be definition of angle bisector. Okay, I know that AD is cutting angle A perfectly into two congruent angles. Okay. Can I do my side next if I'm trying to do angle, side angle? Sure. Okay, so let's do our side. Let's do side AD is congruent to side AD. How do we know that? Good, you remembered. That's the reflexive property of congruence. That says something is the same as itself. And you're just pointing out that the triangles share a side. Reflexive property of congruence. Okay, now for the tricky bit. Because if someone doesn't believe you, you're going to have to convince them. So I'm going to say angle ADC is a right angle. How do I know that's true? RT stands for right. Okay, that was given to me. There was a little box in the corner, so I know that that was given to me. All right, here's the little stretch for you guys today. I'm gonna say the measure of angle ADC plus the measure of angle ADB is 180 degrees. Okay, look at what I just wrote. The measure of angle ADC plus the measure of angle ADB is 180. Do you guys agree that that makes a straight line? Yeah. Okay, there's a couple reasons I would let you get away with for this. You could say they're supplementary. You could throw that word in there. You could also say they form a linear pair, which is kind of like the definition of linear pair. If I was really mean, I would make you show a couple more steps in here, but I'm gonna, as long as you're pointing out to someone that, hey, these are next to each other, so they make 180. That's the point there. Okay, now I'm going to say the measure of angle ADC is 90 degrees plus the measure of angle ADB is 180. All right, that's called substitution. And you could also say definition of right angle. You're kind of using two steps there as well. I'm letting you guys skip a little bit on this one because it could be a really long proof. Okay, so we know ADC is a right angle, and we know the measure of angle ADC is 90. We know the measure of angle ADC is 90 because it's a right angle. Okay, now this is a math problem. This is almost like algebra. 90 plus something is 180. Do we know what the something is? Okay, yeah, we know that the measure of angle ADB has to be 90. Now that is the subtraction property of equality. What I actually did is I took 90 off of this side and 90 off of this side. So this is called the subtraction property of equality. This is how you do deductive reasoning, you guys. Step by step. Lead someone very carefully through what's happening here. Okay, we're almost done, only 2 left. And if you get lost and confused in here, it's okay, but you can also push your brain to try to understand what's happening. We're trying to show that a pair of sides, a pair of angles, a pair of sides, and another pair of angles are congruent. Okay, so our next step is to say angle ADC is congruent to angle ADP. How do we know that? Well, I just showed that this is a right angle. I just figured out that if the one next to it was a right angle, that had to be a right angle. Okay, so that is called, oh, this is one of my favorites. This is called right angles are congruent. If you look back in your textbook, that is actually a theorem. Someone actually took the time to prove that all right angles are congruent. Okay, so now you can use that as a reason in your proof. Anything in the textbook that is a theorem or a postulate that came before it in the textbook, you're allowed to use. So right angles are congruent is one of those things that I've memorized that I know is in your textbook that you can use in a proof. And if someone argues with me, I can go to that page in the textbook and say, look, this is what we agreed upon. Okay, right angles are congruent. Or you could say, hey, this right angle is 90, this right angle is 90, 90 equals 90, therefore they're the same. Okay, and then the last step, whew, we got there. The last statement, remember, is always going to be what you're trying to prove. So triangle ADB is congruent to triangle ADC. And what's our reason? Well, we showed a pair of angles, we showed this included side, and we showed another pair of angles are congruent. Therefore, we have backed up our claim that these triangles are congruent, and the reason is angle, side, angle, triangle, congruence. All right, that's it. Work hard. You can do this. Here it is in your textbook in writing. If 2 angles of one triangle and the included side are congruent to 2 angles and the included side of another triangle, that is enough to say for a fact that the triangles are congruent. Be good, work hard, keep learning.